This video is designed to give you a bit of an idea of how to do some basic data analysis with Excel. It's important to remember that our experiments have lots of repetition, and we don't want that repetition to be a pseudo, in other words, and not real replication, where we're actually just taking multiple samples of the same individual. We need to make sure that in each of our independent variables there are real repeats, in other words, totally new samples. So what do we do with our data? We have a range of samples that is real replication from each of our groups which have had a different treatment. Now we want to know, are those groups different from each other? And to do this, we'll probably go for the average and see if the averages are different. That's good, but it doesn't actually tell us whether the groups are significantly different. That's what we're going to try and do. And to do that, we need to add some add-ins in Excel. In order to do this, you'll need to load some add-ins in Excel. So to do that, you go File, then down to Options, then we are going to go to Add-ins, down the bottom Excel Add-ins, and then click Go. Don't click OK. Once that happens, you can select Analysis Toolpack and then click OK, and it will load for you. If you missed that, here are those instructions in a written form. A quick check we should do is to see whether our data has any outliers in it. A box and whisker plot is a quick way to identify data that may be considered an outlier. If it turns up on a box and whisker plot that it is outside of that data, we then have to decide whether we can or cannot delete it if there's grounds to do that. This is an example of data which does not have any outliers. This plot here has identified an outlier as the dot above the line. We then need to go into the data and determine, was that data point a mistake? Was it written down incorrectly? Or did it actually happen and it's just a very rare occurrence, in which case we need to leave it in. As scientists, we've picked a hypothesis that there will be a difference between our groups. The null hypothesis, as it's called, assumes that there is no difference between the groups, and we're trying to see whether there is a difference through our statistical analysis. Now that we've downloaded our add-ins, we can now get to work on analysing our data. So up in the right here we have, after we've installed that add-in, a data analysis function. We want to select descriptive statistics and then click OK. We're going to select the range, which you can click with this button and select your data. Clicking again will come back to this page. Our data is grouped in this case by columns. We have labels in the first row which signify that that's not data, that's just what they're called. In the output range, this just selects where you would like to have your data come out. Select there, and we want to check summary statistics. Once you've done that, it will give you this block of data here, which we then need to analyse. I'm now going to use the data at the top of this, which includes the mean, which you can see we can already calculate that over here just by using the average function, but what we can't do during using that function is the standard error. I've just cut that data from below and pasted it here so you can see how we create a graph with the standard error as well as the means, and then we'll go on to talk about what that means. So we just want to create a graph from our 4 groups, graphing the average first. So we'll go Insert, and then we can select whatever appropriate scatter plot or column graph we want. Then we're going to add to that. Now in this version, which is 2013, it's slightly different to the instructions on the next slides, but I'll show you how I do it on mine. If we want to add standard error bars, that is above and below these averages, we simply go to the plus sign, and here we've got error bars. So I want to select that and then the little arrow here, and then go more options. Now this puts two sets of error bars. I only want the ones going upwards and downwards, so I will select these and delete them. And then for these ones, it's given me a error which they've created, but I want to go down to a custom range and I want to specify the values. So the values I've got are the ones that we calculated using our standard statistic package. So for the positive error that is above the line, we're going to select this and we're going to select the data. I'll just get rid of our graph so we can see it. I will select specify value. I'm going to put that standard error for each of the dot points as the positive value, and also the same standard error as the negative value. Once I do that and click OK, it will adjust those values so that the standard error is the checkbox above and the little line below. Now, we'll discuss in the next slide what that means. Just again, this is showing how to do it in a step-by-step fashion with a more recent version of Excel. Now that we've got our summary statistics, we want to know how to interpret this. Now this is a very simple way of interpreting whether you've got a significant difference between your groups or whether there's just a difference in the mean, as you can see in these two values, but they're actually not statistically significantly different from each other. And the reason for that is because these error bars that you see between these two values actually overlap. So these error bars here and these error bars here have an area which they overlap. So these two treatments aren't significantly different from each other. However, if we look at this one here, we can see that the error bars from this one do not overlap with the error bars from either of these two results. And that we can see here that that means our results are significantly different. So that's something you can talk about. Here below I've just copy and pasted the example I did in Excel just to show you this also shows that the results you have are significantly different. The treatments you gave were different and therefore significant statistically, or could be. You might have to do a few more tests. Anyway, also to note, you can tidy up your graph obviously by labeling these axes, as I haven't, I've just thrown them in. But yeah, that's something to start you off thinking about how to analyze your data. I hope it helped.